My name is Zachmeier, and the project that has been taking up all my free time this semester is the Water Station Project. This project features 6 tanks, each controlling different aspects of the water like temperature, level, and pressure. When I received this project, it was already mostly entirely wired up. The only modification I made to the actual project was taking it down from 120 volts to 208 volts and putting in a smaller breaker, as there weren't any parts that actually needed 208 volts. Other than that, the physical machine was in pretty good condition. On the programming side, however, the process was a complete catastrophe. There was no organization. The whole thing was the literal definition of spaghetti code, not to mention a complete dearth of documentation within the program and zero safety to speak of. On the documentation side of things, many aspects were inaccurate, incomplete, or just entirely omitted. As far as the HMI goes, I couldn't even get past the security screen, as apparently they changed the passwords and never told anyone, and that it also looked like it was straight out of the 80s in the worst possible way. So with all that, my proposed improvements include, but are not limited to, entirely revamping and updating the documentation, including CAD, both physical and electrical, a list of parts, their information, and pricing, as well as an entirely new PLC program featuring comments, organization, documentation, and safety with an HMI to go along with it that doesn't look like it was made by a 5-year-old that you can actually log into, controlling all aspects of the systems with alarming and trending, as well as guides for all of these. One problem with this is that it's going to take forever for me to get done just the documentation without any actual improvements to the process, but in the long run it will be worth it. As for why you would want one of these, other than being perhaps the most expensive and least graceful water feature on the market, it's really more meant to demonstrate all the different ways you can control water or any other liquid for that matter and advance any system that handles fluids through various facets. Now for an overview of the process in its current state. The water starts in the cold storage station, where it is cycled through a compressor to cool the water down to a set point determined by the user. The compressor is a little anemic, so it typically ends up being about the same temperature as all the other stations, but if it were a little more competent, it would actually be able to cool the water down. The compressor has an on and off cycle time so it doesn't burn out. It's also equipped with other safety features like short cycle protection, watchdog timers, and channel validation. You'll see here later I'll go yank a wire and it will stop because we don't want our analog devices updating from incorrect data. Then it is cycled to the temperature station, where a heater and mixer heat the water to a temperature. Also gave the heater dead banding, short cycle protection, only in auto mode however. I trust that the user won't flash it on and off, although it might not be the best assumption. I also gave it over temperature protection, a watchdog timer in both auto and manual mode, and channel validation as well. The water is then sent to the level station, where a constant water level is attempted to be maintained. I say attempted because it can't fill any faster than it is drained or vice versa, so it can't change its level if it's fighting against another pump, which it usually is. In fact, it can even fall behind sometimes, slowly. However, from there it is pumped into the pressure station, where some of the larger problems start to kind of show up. The 4th pump pumps from the pressure station into a pressure vessel where it attempts to maintain that pressure, but the pump is really weak and can really only pull 4 to 5 psi on a good day and can't even fill it up all the way. Now it's supposed to supply the valve in case the pressure station runs dry, as the valve is meant to simulate the water usage of a hypothetical city, and so you want plenty of water in reserve if the pressure station were to run dry, but it really only supplies the valve even in a low usage state for about half a second before dropping to 0 psi, as again it can't even get filled up. Anyway, you're able to adjust the psi set point, which is changed by opening and closing the variable valve, and you can adjust it from the HMI. The valve, however, is very slow and takes about 30 seconds to go from entirely closed to entirely open, but that's okay because you don't need to adjust it super fast. And I use that time to average out the pressure in real time in the PLC, as it's very jumpy otherwise, and still is quite jumpy, which makes it difficult to read. 2 other problems are that fully opening the valve from it being fully closed will only drop the PSI by about 0.3 to 0.5. The jumpy PSI doesn't make this problem any better. And B, the resting PSI changes by as much as 1 PSI just from day to day, changes in atmospheric pressure, I assume. That or some noise, but I couldn't figure out a way to get it to go away. So I gave a large potential range of PSI set points to the user and left it up to them to set the value. I played around with some auto configuration programming that would open the valve fully, then close it, get the PSIs, and set the high and low that way, but I kind of ran out of time to get that in. Anyway, the final major station is the flow station. So as I mentioned, you'd open and close the valve to simulate water usage by changing the PSI, and then water will flow through the analog valve and then through a flow meter measuring the flow. It can be fun to watch the flow increase as the PSI decreases from the HMI, but that leads us to our final station, which is just a warm storage station where the water is held before being cycled back to the cold storage station through the compressor. Now, all of these stations have safeguard preventing them from being overfilled or drain dry. They also have custom alarms that will pop up, so you see it here if I go and force on some inputs and force the tank to be ran below its proximity sensor, an alarm will pop up telling you exactly what the problem is. If I pull a wire, an alarm also pops up telling you what the problem is and what station it's on. You can also control every station from both the HMI and the physical machine using either momentary selector switches or buttons from the station screen. Other aspects that you can control from the HMI include temperature set points for both the temperature station and the cold storage station, level set points for the level station. You can turn the panel light on and off, and it will turn itself off after 10 minutes so you don't leave it on. And you can even disable individual stations from the HMI, though it does require supervisor level permissions. Looking at the HMI, you can see from the home screen here that you get when you log in, there's a selector switch to change which mode the program is in. You can go to the alarms page, you can turn the panel light on and off. There's a process indicator. You can also change the PSI set point from the home screen because it's kind of the main function of the machine, as well as you can start and stop the machine and even e-stop the machine from the HMI. Looking above the home page, you'll see the system overview. This is always visible no matter what page you're on, and in fact tapping or clicking on them will bring you to that station's corresponding page. From there you can tap the same station again to go back home, as well as tap the home button, or you can tap another station to bring you straight to that station's page. Now the lights on the station overview are meant to represent the indicator lights on the actual machine's command blocks. They are laid out exactly the same as they are in the machine except for the station disable bit. That bit is only on the HMI, and going to that station's page will tell you which lights mean what if you do not know what they are already. Tapping the history button will bring you to the trending page, which will display the pertinent information for that station. Moving from station to station will continue to display the history page until the history button is tapped again from any screen. Finally, you can also change which units are displayed on each screen. For instance, you can change from Celsius to Fahrenheit and back. You can change from liters to gallons, and you can also change from inches to centimeters. You can do this by tapping on almost any displayed unit and it will change. Your unit preferences will be saved across screens and even go into the trending page until you reset it. You can also change the units on the trending page by tapping the legend. This is my program. I don't have time to go over every facet of it, so I'm going to do more of a broad stroke sort of deal. I thought about organizing the program based on station, so level station, temperature station, etc. But the trick with that is one pump affects both stations, so it would work, but I opted to just have one routine for every major output. Looking at each subroutine, the main routine just has the safety okay logic, the system enable logic, so your simple start, stop, and then it just jumps to all the other subroutines throughout the program in no particular order except for the boot up routine is first on the first scan, and the value management goes before any of the other ones. The alarms routine contains all of the timers and bits for the different alarms throughout the program. The boot up routine, as I mentioned before, will just set default values on first scan so that if it shuts down unexpectedly or at all, it can boot up with all the outputs in safe conditions. The compressor logic obviously contains the logic for the compressor. Same for the heater logic. The mode logic contains the logic to keep track of which mode the HMI is in, for instance, temperature mode, Celsius, Fahrenheit, level mode, that sort of deal. It also contains which mode the program is in, manual, auto, off. I used integers here so you could add more modes if you want, and then I used bits to be easily read throughout the program without having to use evaluation boxes. You can just use your normal XIO, XIC bits. Panel light just has the panel light on with the buttons on with the watchdog. Pilot lights just has conditions for the pilot lights. Value management has a lot of logic that just manages the values for the HMI, so it will convert Celsius to Fahrenheit. It will convert raw PLC values to readable engineering units. This is also where my logic that averages the pressure over 5 seconds is, and so on and so forth. It also does latching. And then there's all the pumps. The basic operation of the pumps is that in manual mode, either the selector switch or the HMI will toggle it on or off. And in auto mode, when it gets to its low level, it will run until it gets to its high level. And then there's also safety built in to make sure that if the low procs on the station that it's pumping out of is proc, it won't let it go. And if the high proximity sensor sees water on the station is pumping into, then it will also force the pump off, as well as any other safety bits that go into them. Except for the pump 4, valve 4, which is special, as pump 4 is on almost all the time to try and maintain pressure. And here is the valve logic that updates the valve every second by 300 based on the pressure set point versus the observed pressure. Here is my CAD drawings. I decided to organize them based off of essentially function or PLC card. So there's the safety circuit and high voltage components, and it just organizes it by the cards. So onboard input card, onboard output card, PLC onboard analog card, onboard high speed counter, and then extension input card and extension output card. As far as the physical drawing goes, I also have a general layout of the cabinet. It's not perfectly to scale, as I drew most of these components myself because I couldn't find any drawings of them online. And then I did make a physical drawing for the entire operation just to show general connections of how all the plumbing is connected and where all the parts are. Lastly, when I updated my bill of materials, I gave every part something I call a local number, and this is a number that can be referenced throughout the user's manual. If you ever see a local number, you can refer back to the parts list to get the information about it. You can also go to the sizing if it's on the sizing. It will be on the technical information sheet if there's any wattage or technical information that needs to be known. And you can also match it to the price of the component. I had a lot of fun with this project, and the project also kind of kicked my ass in a couple ways. I was stuck doing documentation and scrolling through Excel sheets for the better part of 3 weeks, which wasn't my favorite, but there was still a lot that I learned in the end. If there was one thing I could change on this project, I would upgrade some of the pumps, perhaps even to an analog pump, as all these pumps were digital. And if I could change one thing about how I approached this problem, I definitely would have planned out my HMI a little bit better, as I certainly ran out of space in the end.